Those who are online are able to hear me?
Yes, sir.
Okay. So if you finish till 20th problem, right? Yeah. So we'll do the 21st one. So it says, find the antiderivative of root x plus.
Sir, we can't see the screen, sir.
Okay. Yeah. Yeah. Find the antiderivative of root x plus 1 by root x. So integral of this value is how much? Right. So integral of root x dx plus integral of 1 by root x dx. So what is the integral of root x dx? How much is it? So it will be x power 3 by 2 divided by 3 by 2. Right. Plus what is going to be the integral of 1 by root x? It will be 2 root x. Right. It will be 2 root x plus c. If you observe the options that are given there, 2 by 3 times x power 3 by 2 plus option C is the right answer. Option C is the right answer. Right. So for the 22nd one, if d by dx of f of x is equal to 4x cube minus 3 divided by x power 4 minus 3 divided by x power 4 such that f of 2 is equal to 0, then we need to find the value of f of x. Right, then we need to find the value of f of x. Right. So for this, what we can do is d of f of x is equal to 4x cube minus 3 divided by x power 4 times dx. So integrating on both the sides, we get f of x is equal to integral of 4x cube is going to be 4 into x power 4 by 4 minus 3 into integral of 1 by x power 4 is going to be equal to, actually it is x power minus 4. So 1 by x power 4 is x power minus 4. It will be x power minus 3 divided by minus 3. X power minus 3 divided by minus 3 plus c. So 3 and 3 will get cancelled. Minus of minus will be plus. So 4x, 4 and 4 will also get cancelled. So what will you have? So it will be x power 4 plus 1 divided by x cube plus c. This is what is f of x. But what did they give? F of 2 is 0. So put 2 here. F of 2 will be equal to 2 power 4 is 16 plus 1 by 2 cube is 1 by 8 plus c. This should be equal to how much? 0. So 16 plus 1 by 8 is going to be equal to. So 16 into 8 is how much? 160 minus 16, 144. So 144 plus 1 is 145, which implies c is equal to minus 145 divided by 8. Take this and substitute it here. So answer should be x power 4 plus 1 by x cube plus, oh, there is no 128. 160 minus 32. 160 minus 32. 128. 128 plus 1, correct. I took 200. Correction. So 16/8 is 128 plus 1, 129. So it is going to be 129 by 8, which implies C is equal to minus 129 by 8. Take this and substitute it here. So the answer should be x power 4 plus 1 by x cube minus 129 divided by 8. So x power 4 plus 1 by x cube plus 1 minus 129 by 8. Option A, no? So option A should be the right answer. A and C look similar, but the difference is constant is negative. It is minus 129 by 8. Yeah, 22nd is option A. Right? Shall we proceed? Right. See, the next concept we are going to discuss is very, very important. Listen to this. We are going to see the concept of methods of integration. Right? We are going to see what are the different methods in which integration can be performed. There are only 3 methods in which you can perform it. Apart from directly finding the answer, there are 3 methods in which you can solve it. One is called as integration by substitution. Okay. One is integration by substitution, means you will take a variable and you will try to substitute it in terms of another variable and then solve it. That is one way. Or there is something called as integration using partial fractions. So integration using partial fractions. And the third one is going to be integration by parts. Right? Throughout the chapter, we are going to see only these methods, right? Of which the first important method that we are going to see is integration by substitution. Okay. First, you can make a note of this. Shall I proceed? Okay. So in this exercise, we'll concentrate on integration by substitution. Right. So let's say we need to find the integral of e power ax dx. Okay, let's look at it with the help of an example itself. If I ask you what is the integral of e power x dx, what is it? We have a ready-made formula which is going to be e power x plus c. But we don't know what to do when this x is changed to ax, right? For that, what are we supposed to do? You need to make sure that this ax is written in terms of some other variable. So the first step is you will equate that variable to one other variable t. So this is the first step. And the second step is differentiate on both the sides. So when I differentiate on both the sides, a times dx will be equal to dt, right? So what you need to do is, after you do this, you need to find dx in terms of dt. So what is going to be dx? Dx will be equal to dt divided by 3. So take this and substitute it here. Integral of, sorry, dt divided by a, right? So take this and substitute it here. It will be integral of e power, instead of ax, I can write it as t. Instead of dx, I can write it as dt divided by a, which implies it is going to be 1 by a times integral of e power t dt. So what will the answer be? It will be e power t divided by a plus c, which is also going to be equal to, what is t here? Ax. So e power ax divided by a plus c. Right? So first is substitute that variable in terms of another variable, differentiate it. After differentiating, find dx in terms of dt and substitute t and dx in the original expression. After that, solve it, right? You will get the final answer in terms of t. Substitute back in terms of the original variable, that will give you the answer. So only these are the steps that we need to follow, right? And this is what is called as integration by substitution. Right? Shall I proceed? Listen to this. So based on this concept, let us solve the example number 5. Okay. The first question is, find the integral of sine mx dx. Find the integral of sine mx dx. So what should the answer be? It will be minus cos mx divided by m plus c. Right? This is the answer, but let's try to solve it. So here, what is the extra term that we have? Instead of x, you have mx. So put mx is equal to t, which implies m into dx is equal to dt. So m into dx is equal to dt, which implies dx is equal to dt divided by m. So what are we supposed to do? Take mx and dx is equal to dt divided by 3, substitute it here. So when you do that, you will get integral of sine t into, what is the value of dx? It is going to be dt divided by m. So you will have 1 divided by m into integral of sine t dt, where the answer is going to be minus cos t divided by m plus c, or this is also equal to minus cos of, in the place of t, we need to substitute that mx back. So mx divided by m plus c. Is that point clear? Clear? Shall I proceed?
Okay, sir.
Yeah. So second problem is, find the integral of 2x into sine of x square plus 1 times dx. Right? Integral of 2x into sine of x square plus 1 times dx. Here, if you observe, right, you have two functions. Observe what is there inside sine. You have that x square plus 1, right? So if I put x square plus 1 as t, what is going to be the derivative? 2x dx. No, you have the 2x dx outside. So in this problem, how we are supposed to proceed is put x square plus 1 is equal to t, which implies 2x dx is equal to dt. So 2x dx can be replaced with dt, and sine of x square plus 1 can be written as t. So sine t dt, which is going to be minus cos t plus c, or it is going to be minus cos of, what is the value of t? It is going to be x square plus 1 plus c. That's it. So that's the answer. Clear? Clear? சொல்றேன். எதுவுமே புரியலையா இல்ல 2x dx எப்படி வந்ததுன்னா அதுதான் அந்த 2x dx தானே ஈக்குவல் டு dt. ஒண்ணுடா நான் கேக்குற கேள்விக்கு ஆன்சர் சொல்லு. இன்டெகிரல் ஆஃப் sin of x square plus 1 பதிலா நான் what can I write? x square plus 1 பதிலா என்ன எழுதலாம்? t ஆ? accepted. இப்ப 2x dx இருக்குல்ல, இந்த 2x dx பதிலா நான் என்ன எழுதலாம்? So அதுதான். So on the 2x dx ஏன் வருதுன்னா, I didn't get it directly. I differentiated this. 2 times x dx plus 0 is equal to dt. Clear? Why are you writing there itself? Your convenience. Shall I proceed? So third. So question is tan power 4 root x into secant square root x the whole divided by root x times dx. Right. So listen to this. See, whenever you're doing any problem based on substitution, right, the first thing is you should understand what should we actually substitute in terms of t. So if you look at this problem, right, everywhere if you observe, since it's a trigonometry, it's a problem based on trigonometry, look at all the angles that are there inside. Everything is in terms of root x. But that's not the only concept. Whenever you substitute something, no, what is the next step you're going to do? You're going to differentiate. So first step is writing a variable is equal to t. Second step is differentiating that variable, and right side you will have dt, right? So this should always run in your mind. Suppose I substitute root x is equal to t, what is going to be the derivative of this? 1 by 2 root x dx will be equal to dt. Now look at this problem. This dx divided by root x is there. No, this is what I want to get eliminated. If you look at this problem, the dx by root x is coming here. So it makes more sense for us to substitute root x is equal to t. Okay. So root x is equal to t. See, actually, this is a direct, it is directly giving you the hint, but I'm just sharing the method of how you're supposed to think. Right. So root x is equal to t. 1 by 2 root x is times dx is equal to dt. Convinced? Right? So dx divided by root x will be equal to 2 dt. So which implies dx divided by root x is going to be equal to 2 times dt. So how will the question get transformed as? Integral of tan power 4t secant square t t, the whole divided by, there is nothing right, whole divided by, no? We don't have, no? Because this dx by root x itself is giving it the answer as 2 times dt. So 2 will come out. Okay, 2 will come out. I'm not writing that extra step. But the trick with this problem is you cannot still integrate this also. The reason being, tan is there and secant square is there. But can we do another substitution to still solve this problem? That is where we have the hint. Always observe, okay? You try to combine two parameters and see how many functions are there here. Two, right? I'm not taking this constant function because it is going to go out of the integral. So out of these two, which one can I substitute it as t so that the derivative of that is present in this? If I substitute tan t as some other variable, the derivative of tan is secant square. Whereas if I substitute secant as some other variable, the derivative of it is going to be secant into tan, but I have tan power 4 here. I'll still get stuck. So what is more sensible? So you need to substitute tan as some other variable. So tan t, you can write it as some other variable, let's say y. There is no y, no? Yeah. We can substitute it as y. So remember the number of terms you're trying to give other variable, the number of times you're supposed to substitute it back. Okay, you need to do the reverse operation also. Don't forget it. I'll explain what I meant. So derivative of tan t, secant square t dt is equal to dy. Now this one should handle this function, right? Integral of, instead of tan power 4t, what can I write? If tan t is y, tan power 4t will be y power 4 into secant square t dt. So secant square t dt combined together is one expression. So secant square t dt is dy, and don't forget you have a 2 inside. So I'll take the 2 outside. Now it is easy to handle. So what is the derivative? Oh, sorry, integral of this? So it is going to be 2 into y power 5 divided by 5. So y is the second variable that I substituted. So I need to do the reverse operation, which implies the answer will be 2 into, instead of tan power 5 t divided by 5 plus c. But t itself is a variable. It's an outside variable. So I need to substitute that. So answer is 2 by 5 times tan power 5 root x plus c. That is the answer. Is that point clear? So when it comes to substitution, it is not necessary you're going to do it only once. There will be some problems where you need to do it multiple times like this. I hope I'm clear. Right? Make a note of. The back side, guys, are you able to see without those two lights? Is it okay, or you have to tell me? And in our light, there is. I'm not able to see the board in the reflection. I'm not sure if you're able to see. These 4 lights are the end of the reason. No, you tell me if you're comfortable, if I can. By tomorrow, I'll do some arrangement so that I'll push it front. For now, can I switch it off? You're fine? You guys are able to see? Okay. Need a? Okay. Okay. Can I switch this off? Okay, maybe I'll try to switch the light there. For today, please adjust. I will do something for the tomorrow. இல்லடா இந்த லைட் ஏதோ வருதா உனக்கு தான் எதுவும் பெருசா தெரியலையா அப்போ ஆஃப் பண்ணிட்டுமா சரி இந்த ஷேடோ வருதுல அதுக்காக பார்த்து Shall I proceed? Right, mark this as an important problem. Try it again. Look at the fourth one. So look at the fourth one. We need to find the integral of sine inverse, sorry. So the fourth problem is we need to find the integral of sine of tan inverse x divided by 1 plus x square times dx. Okay, 1 plus x square times dx. Now, if you observe, most of the problems where trigonometry is involved, whatever is the argument there inside should be substituted as t. So in this case, what is the argument? Argument is the angle. So tan inverse x, but you also have to look at one step ahead and check what is the derivative of tan inverse x? 1 by 1 plus x square, right? So here, if you substitute tan inverse x as t, then you will get 1 divided by 1 plus x square times dx as dt. Clear? So dx divided by 1 plus x square, dx divided by 1 plus x square. Okay. So what will the answer be? Integral of sine t dt. So what will be the answer? Minus cos t plus c, or this is going to be equal to minus cos of tan inverse of x plus c. Clear? Right. Right. So now we are going to derive set of formulae. Okay. Now observe. This is again important. See, if I ask you what is the integral of secant square x dx, so it is going to be tan x plus c. Meaning you differentiate tan x, you are going to get secant square x. But unfortunately, we don't have a direct formula for tan x. So we don't have the formula for tan x dx, right? But is there a possibility that we can derive? This is what we are going to see. It's not only about the derivation, you need to remember the final result also, right? So now what we are going to see is derivative of, sorry, I don't know why I'm getting derivative. Integral of tan x. So now we are going to see the integral of tan x dx. It's very simple, okay? So how will you write tan x as integral of sin x divided by cos x times dx? Now observe which is the derivative of the other. So sine is the derivative of cos, cos derivative will come out as sine. But you need to be smart enough to understand which one should be substituted as t. So always in integration, whenever it comes to a problem, you need to ensure that you always substitute a variable in such a way that the denominator should get eliminated. So if denominator should get eliminated, then what I would do is I would substitute cos x as t. So when I substitute cos x as t, you will get minus sin x dx is equal to dt, right? So sin x dx will be equal to how much? Sin x dx will be equal to negative of dt. So take that and substitute it there. So instead of sin x dx, I'm going to have minus dt divided by cos x is going to be t. So what is the integral of 1 by t? It is log t plus c. So this is going to be minus log of, in the place of t, what should I substitute? Cos x. So minus log of mod of cos x plus c. Okay, actually it is log of mod t plus c. Is it clear till this step? Now the next question is, this is one value. Okay, means the integral of tan x is minus log of mod cos x plus c. This is the final result. There is another way to write this also. Or what you can do is you can write it as log of mod of cos x raised to the power minus 1. Because we know that a log x is equal to log of x power a. You know this, right? So minus 1 will go as the power. The multiplication will go as the power. So plus c, which implies it is log of 1 by cos x. So 1 by cos x is going to be secant x. So the formula can either be log of mod secant x plus c or negative of log of cos x plus c. Both are accepted. Okay. But mostly what we'll do is we'll remember only log of secant x. Okay. Clear? So just make a quick note of it. Make it fast. That's the formula. Yeah, Modna, I told you, no, because log will not take negative values. Log of negative values is not defined. Shall I proceed? I have 40 problems. But this is the most important. Shall I proceed? Listen. So second one, we'll see the integral of cot x dx, which will come out as log of mod sin x plus c. Okay. So let's see how to derive this. Same logic. Integral of cos x divided by sin x times dx. So here it is very simple. Take sin x and put it as t, which implies cos x dx is equal to dt. So cos x dx can be replaced with dt and sin x can be replaced with t. So what are you going to get? You will get integral of dt divided by t. So dt by t is going to be equal to log of mod t plus c, which implies log of, what is t in this case? Sin x plus c. That's it. Log of mod sin x plus c. Right? Shall I proceed? Okay, listen. So the next one we are going to see is integral of, see, we have the integral for secant square x, which is tan x, but we don't have the integral for secant x. So integral of secant x dx is equal to log of mod secant x plus tan x plus c. Okay, this one has to be remembered. Okay, let's see what is the proof for it. So integral of secant x dx, what we need to do is integral of wherever secant comes, no. Tell me one thing logically. So guys, listen. Okay, wherever integral, wherever we have a direct formula for the involvement of function secant, right? What are the two kinds of functions that we have for which we have direct integral? One is secant square x dx, for which directly the answer is going to be tan x. Is this logic clear? So integral of the other place where secant x will directly give you answer is secant x tan x. What is the answer for this? This is secant x. So what is the challenge in this is you neither have that secant square format nor you have that secant x plus tan x format. So what we need to do is we need to bring a combined effect of these two. Meaning, if I want secant to become secant square, what should I multiply with? Secant. If I need secant to become secant into tan, I need to multiply it with tan. So what I'm going to do is, for the secant x, we'll multiply it with secant x plus tan x and compensate it with the same. But did you understand why we are doing this? So that the numerator will become the derivative of the denominator. So come in the reverse, no. What is the derivative of secant x? Secant x tan x. So observe. So when I expand this, you will get secant square x plus secant x tan x, the whole divided by secant x plus tan x. I told you, no, the whole objective of integrals is to eliminate the denominator. If you want to eliminate it, then you should be in a position to write that the numerator is the derivative of denominator. If you observe in the previous two problems also, or previous two derivations also, we did the same thing. If you observe for tan x, no, we wrote it as sin x by cos x. Which one did we substitute it as t? Denominator or numerator? Denominator. For cot x, denominator. For this also, denominator only should come. So for me to get that, I did the secant x plus tan x, so that if I directly substitute the denominator as t, see what you're going to get. Derivative of secant x tan x, I have it here. Similarly, derivative of tan x, secant square x, I have it here. So this will directly become dt. Understood? So integral of dt divided by t. I'm not even showing you the steps. You want me to write and show? I'll do it. So secant x plus tan x, if I substitute it as t, that implies secant x tan x plus secant square x dx is equal to dt. This whole thing is numerator and this thing is denominator. So it is dt by t. So what should be the answer? Log of mod t plus c. So what is it? Log of, you should substitute the t back. No, what is t? Secant x, sorry, here, secant x plus tan x. That is why we have this as the formula. Is that clear? Right. So remember this one. Okay. Anyways, nobody is going to ask you the proof, but the final result needs to be remembered because we'll be applying it in advanced problems. Okay. So make sure you remember it. Advanced, tough on problems, higher order thinking skills. JEE advanced career. Is that doubted, Pranav? What happened? Next. Done. Okay. So look at the fourth one. We need to find the integral of cosecant x dx, which is going to be log of mod cosecant x minus cot x plus c. Okay. Same logic. Okay. Observe. So integral of cosecant x dx. Tell me what are the two integrals for where cosecant x is involved and we directly know the integral. Integral of cosecant square x dx is actually negative of cot x. Similarly, you have integral of cosecant x cot x dx, which is going to be equal to negative of cosecant x. So both are having minus only. So what are we supposed to multiply and divide it with? The sum of these two. Right? Because see, what I want inside the integral is, think of the logic. I need cosecant square, I need cosecant into cot. So what I need to multiply and divide with this cosecant x, if I leave it. If I want cosecant square, I need to multiply it with cosecant x. If I need cosecant into cot, I need to multiply it with cot x. So I need to compensate with the same. Make sense? Make sense? Right, after this, it's easy. Right. So integral of what will you have? Cosecant square x plus cosecant x cot x, the whole divided by cosecant x plus cot x, the whole times dx. If you observe, if I put the denominator as t, if I put cosecant x plus cot x is equal to t, right? Then what is going to be the derivative of it? Minus cosecant x cot x minus cosecant square x times dx is equal to dt. Or if I take the minus outside, if I take the minus outside, if I put plus and plus, if I put the minus here, it makes sense. So I can take the minus to this side. Now tell me, just to avoid one step, concentrate. What I'm doing is cosecant x cot x plus cosecant square x times dx is actually minus dt. Meaning cosecant square x plus cosecant x cot x times dx is going to be equal to negative of dt divided by cosecant plus cot is going to be t itself. So what will the answer be? This is going to be negative of log of mod t. But what is t? Cosecant plus, right, plus c. But if you see this and this, they do not match. Where minus? What I wrote is correct. There is no mistake in it. But they both are not matching because there is this minus outside. No, I need to do something with it. So this is also accepted. This is also right. Okay. Because when you do the same thing, when it comes to definite integrals, it doesn't make difference whether you're going to use this or this. Answer will be the same. Right. But listen to this. Log of this there. No, if I take the minus here, what will happen? Cosecant x plus cot x raised to the power minus 1. So it is going to become 1 divided by cosecant x plus cot x. Accepted? Am I clear with this step? Everyone? Okay. Plus c. But how can I write 1 in terms of cosecant and cot? So there is an identity which says cosecant square x minus cot square x is equal to 1. So this one, I can write it as cosecant square x minus cot square x, but still this can be simplified as cosecant x minus cot x into cosecant x plus cot x is equal to 1. I will use it here. So if I use it, log of mod of cosecant x minus cot x into cosecant x plus cot x, the whole divided by cosecant x plus cot x plus c. So cosecant x plus cot x and cosecant x plus cot x will get cancelled. So what I left out with? Log of mod of cosecant x minus cot x plus c. So one important point I would like to stress here is, you would have observed we did manipulation for two formulae. What are they? One is for tan x. For tan x, we got two formulae. What is it? Minus log of cos x, or it is also log of secant x. I told you both are accepted. In a similar way, for cosecant x also, you got the answer as minus log of cosecant plus cot, or it is log of cosecant minus cot. Both are accepted. So it depends on where you are leaving that particular problem. So to put it simple, going forward, whenever you're doing problems based on trigonometry, listen, whenever you're doing problems based on trigonometry in indefinite integrals, multiple answers will come. So as I told you, it depends on your perspective. If suppose this is treated as a problem, if you're going to leave it with this step, you're still right. If you're going to go a step ahead, manipulate and write it in this way, you're still right. So that is why both the answers are accepted. The same thing will come even when you solve real-time problems also. So there's one point I would like to stress. What did I say? Whenever you're solving problems based on trigonometry, in which integrals? Only in indefinite, because definite will give you only one answer. So you're going to substitute the limit. There things cannot change. Whereas indefinite integrals, you're not substituting any values. So there is a possibility you will get multiple answers, but still it will be right. How to validate whether it is right? If you differentiate this and get back the question, you're still right. So whatever final answer you're getting, if you're able to differentiate it and you're able to still get back the question with which you started with, you are right. That problem will occur only for trigonometry. Others will be taken care. Algebraic and all, you'll not get multiple answers. It will be the same answer. Is that clear? Problem that will follow. The secondary goes as all after. 40 problems. I do it fully. They want to keep the taking from the same topic. There's no doubt. Raman, any questions?
No, sir.
Okay. Then we'll wind up.
Thank you, sir.